I think there's like a couple of rumors here, so we have to do a spiel. We're here. Yeah, I'll do the entire spiel for the. Checking my heart rate for the last 30 minutes. Not a good idea. You'll be fine.
All right, everybody. Welcome to the Node.js meetup. So I'll find our way to our seats, and we'll get started with our feature talk tonight. So before we begin with the actual talk tonight, we'd like to first begin by thanking the sponsors for the meetup. The space here has been provided by Code Talent. They're an awesome technical recruiting agency. I don't think there's anybody here from Code Talent right now, though, right? No, they often sort of let us hang out here all night. So they're really awesome. I don't actually even know if they have any business cards out here, but if you have any technical recruiting needs, they're a great company to contact. Also, they provided the drinks and the beer and the water over there. Google provided the pizza for us. So our monthly reminder to please remember Google when we're searching for our technical needs. As if we don't use them already. And that's what we have for sponsorships. Does anybody have any sort of announcements they'd like to announce to the entire group while we're all hanging out? Yes.
I am also a recruiter, so me too.
Bring beer next time.
I can do that.
Anybody else? Going once, going twice. All right, and then we're also recording this talk and live streaming it to the internet. So in the future, if you want to look back and actually watch this again, you don't have to take notes. I'll post a link to it once it's archived on YouTube into the Meetup channel. Also, we'll be posting that out to my Twitter feed and also on Denver Devs Meetup. So if you're not, Denver Devs Slack. So if you're not on there, also I recommend joining there as well. Yes.
What's your Twitter?
What's my Twitter? My Twitter, well, I will, hard to show that right here. So I will put that on the, what? Sure, yeah.
It's like Brooks Builds?
Brooks _ Patton. I know, that's my Twitch name. That's not me.
I had it there, I just had the
There you go, that's my Twitter. And of course, we're live right now, so if anybody online has any questions during the entire time, I will be asking those questions during the appropriate call for questions. So any last comments or anything else before we hand it off to Michael for the talk? All right, so without any further ado, Michael.
All right, thank you, Brooks. Thank you to our sponsors, Code Talent and Google. And most importantly, thank you to you all for coming out. We couldn't do this without you. Well, I guess we would just be talking to ourselves. So as I'm going through this, I definitely can start speaking really fast. So if somebody could just do one of these, or something to indicate that I need to slow down. Am I already going too fast? Or am I good?
Doing great.
Doing great. Okay, thank you, Pete.
Go faster.
Faster, okay. All right, so yeah, I had about 45 minutes of material here. I can do it in 15, but it's like kind of doing like the 10-minute abs in like 2 minutes or something like that. You probably won't get too much out of it. So yeah, I am Michael Herman, and I'm going to be talking about Kubernetes today. So in terms of tonight's agenda, so I'm going to talk a little bit about myself, go over some objectives, and then I'm going to dive into some theories. I'm going to talk about container orchestration, go over why application developers might want to learn Kubernetes, and then dive into some of the Kubernetes primitives. And then I have a demo where I'm going to deploy a Node and Postgres application onto Google Cloud Platform. And then we should have some time for questions at the end. Okay, so a little bit about myself. So I am a software engineer at ClickFox. ClickFox is known as the Journey company. Basically, we take big data analytics, we take analytics across mediums, combine it. It's a lot of big data, so if you're interested in ClickFox, happy to chat about it afterwards. I believe we're hiring right now, like across the board. It is an Angular app on the front end, so it's not the sexy React at this point, but if you are interested in Angular, definitely talk to me afterwards. Other than that, so I'm the co-founder, author of RealPython. RealPython is a training course that also goes into web development. My co-founders and I, we did sell RealPython within the last year, so my new side hustle is teststring.io. Pull that up real quick. So teststring.io is a microservices course, big surprise. Goes over Docker, Flask, and React, and also shows how to scale those services on Amazon. So it's built for application developers that kind of want to move over to the platform side, or platform developers that want to move over to the application side. So it's kind of like that medium in the middle there. Other than that, I love listening to Radiohead, and I love listening to Radiohead while writing tech education, building open source projects, and building financial models. So that's a little bit about myself. All right, so some objectives. So by the end of this talk, you should be able to explain what container orchestration is, discuss the pros and cons of using Kubernetes over other container orchestration tools, configure a Kubernetes cluster to run on Google Cloud Platform, and deploy a Node and Postgres application on Kubernetes. So before I jump in, who here has worked with Docker before? Cool. Who here has worked with Kubernetes before? Okay. All right, and I assume most of you are application developers? Okay. About 50-50? Okay. Okay, so in terms of theory, so what is container orchestration? So the definition that I have used a lot is, as you move from deploying containers on a single machine to deploying them across a number of machines, you'll need the orchestration tool to manage the arrangement, coordination, availability of the containers across the entire system. So what does that mean in plain English? So you take a Node Express application and you containerize it, and you've deployed it, say, on like an EC2 instance. You have a load balancer in front of it, traffic's hitting the load balancer, and then you're forwarding the traffic on to your Node Express instance. You may have written a blog post, and it may have gotten #1 on Hacker News, and you're starting to get significant traffic. So you start scaling out vertically. So you start increasing the processes on that instance. You start adding more RAM. You get to the point where you can only scale so much on that single instance. So then you need to spin up another instance, another server, and spin up another application on the server. How does the load balancer know that you've spun up that instance? How does the load balancer know that that's in the server pool there, that you can, you hit the load balancer, and then how does the load balancer know that, hey, that instance is available to take in the traffic? So that's exactly what container orchestration solves. Some of the issues that container orchestration tool solves, other than the cross-server container communication that I just talked about, as well as horizontal scaling, service discovery. So you spin up a new instance, how does the overall system know that the instance is there? Security, zero downtime deployments, and rollbacks. So that's exactly where Kubernetes, as well as some other container orchestration tools, such as Docker Swarm, ECS, Mesos, and HashiCorp's Nomad fit in. So which container orchestration tool should you use? So in my opinion, use Kubernetes if you need to manage large, complex clusters. Use Docker Swarm if you're just getting started and don't need to manage a small to medium-sized cluster. And then use ECS if you're already using a number of AWS services. And so some of the pros and cons for each of those: Kubernetes, large community, very, very flexible, has most of like the bleeding edge features. It's also super hip. Cons, complex setup, high learning curve. It's also super hip. So you can kind of notice there that I put hip on both sides there because, haha, it's a little joke. Docker Swarm, easy to set up, perfect for smaller clusters. You're limited by the Docker API there. So, with that said, if we go into Docker here and hit Preferences, there is a Kubernetes tab, and so you can enable Kubernetes within inside Docker. So Docker is a Kubernetes is a first-class citizen inside of Docker. So you can actually run your Docker stack commands, which would normally run against Docker Swarm. So Docker Swarm, again, is another container orchestration tool, but you can actually run that against Kubernetes if you want to. So I think this is good for beginners. Being limited by the Docker API allows you to get something up really, really quickly. And then ECS, Elastic Container Service, fully managed service, you're integrated with AWS, you do have vendor lock-in there. And besides that, the trend these days is sort of these managed Kubernetes services. So there's GKE, that's Google Kubernetes Engine. That's the one I'm going to be demoing today. There's also EKS, which is Elastic Kubernetes Engine. That's AWS's flavor. DigitalOcean has one. Azure has one as well. I can't think of the name of them now. But really, as an application developer, you kind of want to answer this question. Do you want to manage a Kubernetes cluster, or do you want to deploy your apps? I would lean more towards the latter, and I would probably use a managed service at this point. And I do have a blog post here that, or reference a blog post here that kind of goes more into container orchestration tools. And we'll post these slides afterwards. Okay, so I don't know, about a year and a half ago when I was starting to look at container orchestration tools, I sort of jotted down a feature wish list. And so these are some of the features that I was looking for. Health checks. You spin up a new instance of your Node Express app. How do you know that it's healthy? So you want to ping it maybe every 5 seconds. As long as you get 200 response back, maybe you can assume it's healthy. But maybe you need to go deeper and actually look at like the JSON payload or something like that. Dynamic port mapping, so ports are assigned dynamically when the container is spun up. So you have a Node Express app, it's running on localhost 3000. Localhost 3000 inside the container, you're also exposing a port outside the container. You can't obviously expose more than one container on that port 3000, also port collisions there. So those need to be dynamically assigned. Zero downtime deployments do not disrupt end users. So you spin up a new instance, maybe you have 50% of your traffic going to this single instance, and then you have 50% of your other traffic going to like the original instance. You can also start doing some like A/B testing there, where hey, you spin up a new like experimental instance, and you turn it on for like 10 minutes, route like X amount of traffic there. Spin it down, and then grab the logs, and then you can start like looking at what users are actually doing. So Google actually does this. They don't turn on for 10 minutes. They turn on for like 10 milliseconds, and they get a crap load of traffic, and then they turn it off, and then they grab the logs and the the monitoring and whatnot, and can make inferences based on what users are doing at that point. Where was I? Server downtime deployments, service discovery. So automatic detection of new containers and services, kind of already talked about this. Spin up a new instance, the entire system, the load balancer needs to know about it. Auto scaling, so you're scaling your resources up and down. Probably would also have a floor and a ceiling there. So a floor of like maybe you have 5 servers that are always going to be up, so you're not scaling like all the way down to 0. And then a ceiling of servers, so that you're like the ceiling is 10. So you hit number 1 on Hacker News, get a crap load of traffic. You don't want it to scale out to like 100 servers, just cap it at 10. And then, so provisioning some new containers should select hosts based on their resources and configuration. So what am I missing there? Load balancing, logging, monitoring, authentication, and security. Okay, so Kubernetes for application developers. So most, or I guess 50% of you application developers out there, so why the hell should I care about this crazy thing here? So I would say, with microservices in general, smaller teams, smaller projects. What does that mean? Increased velocity. You can move faster. You can ship more code quicker, safer, more reliable. You do have fewer bugs there. You can also work with like the latest tools and technologies. So with microservices, API contract is what really matters at the end. It doesn't really matter how that service is implemented. You wouldn't want to use Cold Fusion, because then you're kind of like, locked in there, and then you have to pay a Cold Fusion developer, but you could if you wanted to, and then you just have the API there. So increased velocity, that appeases product, fewer bugs, that appeases developers, latest tools and technologies. So smaller teams, smaller code bases, generally happier developers. So I like to think in terms of abstraction layers. So virtualization is obviously something that we have taken advantage of in the past X amount of years, as well as containerization. So I think I started working with Docker back in 2014. At this point, it's like just something that we kind of like have to deal with. So virtualization and containerization are solid abstraction layers. And I strongly believe that solid abstractions provide consistency across platforms, and this leads to standards, best practices, and de facto rules. So it's kind of out there whether Kubernetes is going to be the next solid abstraction layer. I'd say that container orchestration is just something that if you're going to be deploying Docker production, you really need it. And so Kubernetes is the leader and has the leading market share, lose my words here, but it's basically out of all the container orchestration tools, it's number 1. It has like 60 or 70% of the market share there. So I think the word is still out on whether we're going to be using Kubernetes 10 years from now, but I think that it is, I don't know, it seems like it's going to be there. And so whether it's Kubernetes or some other tool, I think that it's something that we kind of need to get used to in terms of abstraction layers. So, as application developers, you're probably not going to be launching or, managing a Kubernetes cluster, but you will use that cluster. You will take advantage of it just like any other platform as a service. And so it definitely helps to have a solid understanding of that underlying architecture in order to debug and deploy your applications. So, with that, I'm going to dive into the actual Kubernetes primitives, unless there's any questions. Sweet. Okay, so the primitives. Sorry, I just kicked the camera there. Okay, so the primitives. I'm going to go over node, pod, service, label, deployment, and volume. So this is definitely not all of the primitives. These are the ones that I'm going to go through in the demo. I would say that a pod, a service, and deployment are the ones that you really need to know if you're going to start working with Kubernetes. So try and pay the most attention to those. Okay, so a node is just a worker machine provisioned to run Kubernetes, and each node is then managed by the Kubernetes master. So all that means it's just a machine that's provisioned to run Docker and Kubernetes. It could be your local laptop, it could be an EC2 instance, it could be a DigitalOcean droplet. It's just a single machine. And the definition that I have for a pod, it's overly complex just to show off a bit, but a pod is a logically, thank you. A pod is a logical, tightly coupled group of application containers that run on node. Containers in a pod are deployed together and share resources like data volumes. Multiple pods can run on a single node. What does that mean? A pod just runs a container. So it runs Postgres, it runs Node, you could run whatever your application container is. It's going to run on a pod. So you can see here the diagram I have here. So you have your cluster, we have two nodes. Again, as a node, there's a machine that is provisioned to run Kubernetes, and then we have our pods there. So we can have multiple pods on the node, and then we have our applications here. So in the demo that I'm going to show, for our pods, we're going to run Node on one pod and Postgres on another pod. So that's a node and a pod. So a service. So a service is an abstraction layer over a pod. So pods are meant to come up and down, while a service is meant to it's an abstraction layer over that. So traffic comes in, hits your load balancer, and then traffic will then get forwarded onto a service. And then as soon as it hits the service asks, hey, which pods do I have available? And then it will forward traffic on appropriately. And a deployment, so that's used to describe the desired state of Kubernetes, and they dictate how pods are created, deployed, and replicated. So a deployment is just used to spin up pods. It's another abstraction layer. So one thing you might have noticed is that Kubernetes is very, very, very loosely coupled. Other container orchestration tools, especially Docker Swarm, it's a little more like highly coupled. The resources are a little more coupled together. That's what makes Kubernetes kind of difficult to learn. But once you learn these concepts and understand how it's all glued together, it makes deploying things a lot easier. So this is the sort of the diagram I have for a service. So we have our cluster there, and like I was saying, traffic comes in, hits the service, and then the service is, figures out which pod to deploy to. So we could have like version 1 of our application here, version 2 of our application here, and then like we have X amount of traffic go here, X amount of traffic go here, and these pods go up and down at will. And so the service is just sitting there. It's more permanent than the actual pods. A label, so labels are key value pairs. These are attached to resources, and they're used to organize related resources. And so you can think of them like CSS selectors. So the examples I have here are, you can break them down by environment. So you have dev, test, prod. You could have UAT, staging, that sort of thing. Your app versions, beta, 0.0 or 0.0.1, that sort of thing, and the type. So back end, front end, that sort of thing. Volumes. So volumes are very important for stateful applications, and these are coming from, if you're familiar with Docker volumes, it's the exact same thing. So Docker containers, they are meant to be spun up and down at will. You obviously can't do that with anything that has state in it, so you need to actually pipe the state out of that. You need to keep the state of Postgres, or I don't know why I put Redis on there, because Redis is usually in memory, but regardless. Yeah, if you have your Postgres state, you don't want to keep that in a container. because your containers come up and down at will. And if you have your container come down, then you're going to lose your state. So you need to keep the state outside the container. That's where volumes come into play. So again, a volume is a Docker term. And in Kubernetes land, we have a persistent volume and a persistent volume claim. So continuing on with the previously coupled nature of Kubernetes, you can think of a persistent volume. That's basically where the data volume is. Persistent volume claim is just a claim on that data. So your application, your pod, will say, hey, I need to access that volume, so I'm going to make a claim to it. So the relationship there is application, claim, and then the volume. And I'll go over a further example of this, so hopefully that'll make more sense in a bit. Okay, so I'm going to take a breath.
On volumes, are you using volumes in production or just locally for development?
No, you're definitely using production. Yeah. And I'll go over an example of how to do that in a second. And I'll try to remember to repeat the question, but the question was, do you use volumes in production? And the answer was yes. That's the most important place that you want to use a volume. So, okay, so to create a new object in Kubernetes, you provide a spec. And so that describes the desired state that you want of your Kubernetes cluster. And so I most always do this in YAML files. You can do this from the command line, but that kind of goes away from, I don't know if you've heard this concept called infrastructure as code, where you basically want to be able to spin up your infrastructure really, really fast, and then also version control it. So if you're spinning up everything from the command line, you're not able to throw that into Git. So if we're using these YAML files, then we can throw them into version control, and we put them up to Git, run Jenkins builds on them, blah, 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 blah. So it's really good to actually create these YAML files, and there's other sort of configuration files that can be used as well. So this is just a basic YAML configuration file. If you've worked with Docker Compose before, it probably looks similar to Docker Compose. So some of the required fields here, or the required fields here, are the API version, the kind, some metadata, and then the spec. So the API version is that Kubernetes API version. The kind is the type of object. So if you think back to the primitives, deployment, pod, service, volume, that sort of thing. And then some metadata about the object, and that's generally where your labels are going to go. Remember, labels are sort of like the CSS selectors, so you can reference them really fast. And then you have your spec. So the spec is where the meat of this really is. So replicas. So again, the deployment is spinning up pods. So this is all the same. I want one pod, so one application of whatever is going on in this container. So you can probably guess this is a Node Express application, because the name is Node. This is Node.js meetup, but this is pulling an image, Node-Kubernetes, and the tag is version 0.0.1. So all of the specs are going to follow the same sort of pattern here. Okay, that's all I have for theory. Before I go into the demo, any questions?
Sorry, I'm just a little fuzzy on how Kubernetes is different than Docker, like what it's doing differently, or I don't know, can you just explain that a little bit more?
Yeah, so the question is, what's the difference between Docker and Kubernetes? So Kubernetes rests on top of Docker. So it's just abstracting out Docker, and it's just organizing multiple containers together and getting them to communicate together. I don't really have a better definition than that, but yeah, it's just, when you need to start horizontally scaling your application, when you can't rest on Docker at that point. You can spin up individual instances on, say, like an EC2 instance, but as soon as you're starting to spin up multiple EC2 instances and multiple versions of your application out there, you need some sort of system over that that is keeping track of that entire system. And so that's where Kubernetes comes into play.
Thanks.
I think I didn't quite understand what the difference is between a deployment and a spec. You said a deployment describes the desired state, but it kind of seems like a spec does as well. I feel like I'm missing something there.
Yeah, it's a good catch. So I think my definition, if I had, I actually wrote these, that version of the slides probably 2 months ago. If I had to rewrite them, I'd probably write the definition a little bit differently of the deployment. So yeah, specs in general describe the desired state, whereas a deployment is really, describes like the desired state of your pods in general.
Okay. So it's like a lower level spec in that sense?
Yeah, I mean, it's just like a subset, but I mean, what it does is it just dictates your pods, like the state of your pods. Yeah.
So the service component, where does it reside?
I missed that. So the service.
Component that you were explaining?
Yeah.
Where does it reside? Does it stay in the pod, or is it, where does it reside?
Well, so there's multiple types of services. There's a cluster IP, there is a node port, there's a load balancer, and there's an ingress. The example I'm going to show, basically the service is going to spin up a load balancer on GCP. So if you're doing an ingress, it would spin up a sort of like a separate container. I think a service is kind of like a strange object because it's always going to spin up like another object, like on top of that. I don't know if that kind of answers your question or not.
Not truly. I think the example will explain it.
Okay, all right.
I'll ask again.
Okay, perfect. Other questions? Cool. Okay. All right, so I'm going to take one hand here. We'll see how this goes. So the application that I'm going to be going over is just a basic Node Express, Postgres to do CRUD app. So I'm going to pull up the code real quick. And I'm going to start by showing the Docker Compose file, because that is like a nice broad overview of what's actually happening in the code base here. So I have two different services. Let me zoom in a bit. So I have my web, which is a Node Express app, and then I have Postgres. So web, the build context is the root directory, so that's going to be where it's going to look for the Docker file. Setting some environment variables, exposing port 3000 to other services, exposing port 3000 externally, and then Postgres and pulling an Alpine Postgres version from Docker Hub, and then setting some environment variables and exposing port 5432, which is the default Postgres port, to other services. Going back, so here's the Docker file for the Node application, so Node Alpine version, specifying a working directory, copying over my package.json, npm install. You guys are all Node developers, I hope, so you can all understand what's going on here. Installing Connects. Connects is a query builder, so I can write JavaScript instead of SQL. Copying over my root directory, exposing the port, and then running npm start, which runs my server. So we look at the source directory, or DB, just have all my migrations, have my database seed. We go into the source directory, or sorry, the server file here. So you see we're standing up Express, and then I have all my routes here, and I'll talk about the routes in just a second. And then under the Kubernetes folder, here's where all my Kubernetes specs reside. And we'll talk about those in a second. So that's the basic code there. In terms of routes, so I have a main route there. It's just a quick sanity check. In terms of the CRUD routes, you can get a to-do, get all to-dos, get a single to-do, blah, blah, blah. So that's the application that I'm going to be deploying. And to show that it actually works with Docker, there's no way that anybody can actually see that. I can't even see it up here. Kind of see that, Docker. Should I zoom in more?
10 times.
Okay. 10 times more? What about 9 or 11? Okay.
Too much.
That's 11. Are we okay with that? You want to go down to 10?
That's great.
Now, for whatever reason, it duplicated that many times. Okay, so I ran my Docker compose up-d -build command. So that, what does that do? That builds my images and then spins up my containers. This went really fast because I've already pre-cached these, because you don't want to sit here and watch me do this, because in America, silence is awkward. So, all right, got that spun up. So this is running on localhost 3000. So, how about Pong? All right, so there's my sanity check. If I go to my to-dos, you don't really need to see that, but that's like just basic JSON responsive to-dos. So the application is up and running. So that is up and running locally. Now, let's get this on GCP. So, GCP, Google Cloud Platform. What is it? Just a bunch of cloud services. If we go to Google Cloud, so you can see all the different services over here. So I have my compute engines, storage. You can see, the relational SQL databases here. Some networking stuff, logging, blah, blah, blah. Big data, machine learning, that sort of stuff. So really, this, if you're familiar with AWS, this is just Google's flavor of AWS. So to work with Google Cloud Platform, you could spin up everything directly in the console, or you could use the Google Cloud SDK, which is what I'm going to be using. So to work with Google Cloud SDK, you need to install it, configure it to work with your credentials, set up your account, billing, that sort of stuff. And it's worth noting that Google does give you like $300 worth of free credit. I think you have to use it within a year before it expires, and you can use that to just get going with stuff. And then you need to set up a project. So I've already done all that. Thankfully, I wrote a blog post that talks about how to do all this. So if you are interested in learning how to do all this, check out this blog post. I will post a link to it afterwards. But this tells all about how to set up Google Cloud SDK. So then you need to install kubectl. What the hell is kubectl? I have an answer for you. So kubectl, it is a CLI tool that you can use to interact with Kubernetes clusters. That's all it is. So you can run, so you just interact with the Kubernetes API through it. So there's multiple ways to install kubectl. However, since we already have the Google Cloud SDK installed, we'll install it via the Google Cloud SDK. So, if you're familiar with Brew, you can install it via Brew. There's other ways to install it too, but I've already installed this, so that's why it's giving me all components are up to date. Okay, so after that, we want to create a cluster on GKE. So GKE is Google Kubernetes Engine. So I'll pull that up real quick. So I already have a cluster set up. And so you can see here, gcloud container clusters create. So the name of the cluster, node-kubernetes. 3 machines associated with it. The zone, US Central 1A, it's Iowa. Just a little trivia, Pokemon Go launched they launched everything in this region, so it must be a pretty good region. And then the machine type is F1 Micro. F1 Micros, I think, is the smallest machine. So if we take a look at this on the console, control it in here, scroll down, And you can see the pool here that I have. So you can see there's 3 nodes associated with it. The machine type F1 micro. Each of those machines has 1 virtual CPU and 0.6 gigabytes of memory. So not very heavy machines there. But since I'm trying to stay in that free tier, $300, gotta go light. Not doing just Pokemon Go bullshit. Okay. So, you can also check the status of things via the kubectl. You can see that this has been up for about an hour. So I spun it up, 6:45, I think. Okay, so next you want to point kubectl at that cluster, so you can run this command here, because you can have multiple clusters going at one time. And so that's set up. So, in recap, you need to install SDK, you need to configure with your account, you need to set a project, you need to install kubectl, you need to create a cluster. This will create 3 instances on the compute engine, and then making sure it's up, and then pointing kubectl at that cluster. And actually, I'm going to start calling kubectl kubectl, because I like that better. If anyone doesn't like that, well, yeah. Okay, all right. Questions thus far? Okay, all right, so, this is the stack that we're going to be standing up here. So you can see all of the objects here. Hopefully some of these names ring a bell. So you have service, deployment, pod, volume, that sort of thing. So we're going to stand up persistent volume, then we'll stand up the claim, we'll then spin up some secrets. I'll talk about what secrets are in a second. We'll then spin up our deployment, which will spin up the pod. The pod will then communicate with the claim as well as the secrets, and then we need to expose port 5432 to the rest of the cluster, so we need a service to do that. That's the Postgres side of things. On the node side of things, we'll then spin up a deployment, which will in turn spin up a pod. That pod will communicate with the secrets, because that's where our database credentials are. And then we need to expose that to the rest of the world, so we're going to spin up a service. This will go a lot faster than it looks like. You're like, I'm going to be here all night, I can't deal with this. But I'm telling you, it's going to go fast. So, all right, let's get to it. So, again, if you go back to the code, I have all my YAML files here. So everything that you see in the slides are actually also on version control here, so you can get access to these if you want to use this. So we have our API version, so version 1. We have our kind, so persistent volume. So if you remember back when I was talking about the Kubernetes concepts, persistent volume is just where is actually your data volume. We have some metadata, and then we have our spec. So in terms of the spec, we have capacity there, so I'm getting 50 gigabytes of storage. Don't worry about storage class name for now. Access nodes, read-write once. This can only be mounted once by a single node. So use it once, you can't use it again. And then I'm using GCE persistent disk. So I think there was a question about whether you should use volumes production. So this goes back to that question in terms of this is installing a disk, a file system that you can use. Extension 4, that's some sort of Linux file system. I don't know much enough about that, but I know this is going to spin up a disk on GCP where your data is going to reside. So the first thing you need to do is spin up that disk. So it gives a warning that the disk is under 200 gigabytes and you're screwed. Just ignore it since it's a demo. So now that disk is spinning up. So now I'm going to actually create the volume. And then now I'm going to check the details of that volume. So what are we looking at here? So you can see the name of the volume, that's Postgres-PV, capacity is 50 gigabytes. The access node read-write once, And you can see there's not a claim associated with it yet. So that's a segue into getting the claim going.
Super quick, can I assume there's a whole other set of tools for giving that database like resilience and scalability and all that jazz that we don't have to talk about? But...
Yeah, so the question is all about like high availability and databases. Yes, there is like a whole other side of that I'm not going to go over today. So we go to the console real quick. So if I go to compute, and I go to disks, holy crap, you can see my disk there. So you can see the name of the disk there, and then you can see it's 50 gigabytes, so it actually does exist. Okay, moving on, so now we have our volume up, so now in order for our application to take advantage of it, we need to set up a claim. So the claim, API version 1, persistent volume claim, some metadata there, we're requesting all 50 gigabytes. You can see the volume name there. So Postgres-PV. So that relates back to the claim right here. So that's how those are linked together. And so, go ahead and create the volume claim. So now if I do kubectl get PV, you can see that now there's a claim associated with that right here. And if we go back to the console, and I go to Kubernetes engine, and I go to storage, you can see the claim there. So Postgres-PVC, the claim in the volume is Postgres-PV. So this is actually spinning up stuff in real time. It wasn't there before. Okay. All right, so we can also run this kubectl get PVC, which will actually check the details of the claim. Okay, so we have our volume set up. We have volume claim set up. So now we don't want our database credentials in clear text. So we use a secret for that. So a secret holds sensitive information, PII data, passwords, API tokens, SSH keys, that sort of thing. So again, API version 1, kind is a secret, the name, Postgres credentials, and my data here. So I have a user and password. And this is security by obscurity, base 64 encoded. Anybody that has access to the Kubernetes cluster can decode this, so this is not encrypted. If you're interested in encrypting it, I recommend HashiCorp's Vault Console. I think Kubernetes now does allow you to encrypt things, but beyond the scope of the presentation here. So this, the username is sample, and the password, I think, is please change me, or something along those lines. So we can add the secrets. And if we hop up to the console here, we go to configuration, you can see my secrets. Postgres credentials is the name, and you can see that these are not viewable, but again, you can access these and decode them. They are just base 64 encoded. Okay, so we have a volume set up. We have the volume claim set up. We have our secret set up. Now we can set up our Postgres deployment, and this Postgres deployment will spin up our pod. And the pod is where our application runs. So, opening up the YAML file here, again, the kind is deployments, API version you can see here, some metadata, replicas, means I just want to spin up one instance of Postgres, and you can see my spec here. So, what is going on here? So, pulling from an Alpine version of Postgres, from Docker Hub, see my volume mount here. So, the name of the volume mount, Postgres volume mount, relates down to here, Postgres volume mount. And I'm using the persistent volume claim. So this happens to be the claim name. So that is how you connect the volume claim to the deployment. From there, I have some environment variables. So I have a Postgres user and Postgres password. This is using the Postgres credential secret that I just set up. And you can see the key of user, the key of password. So that's referencing the key of user and the key of password from my secret. So that's how all those things are lining up. Hopefully this helps iterate the fact of how loosely coupled things are in Kubernetes now.
Those capital strings, they will be exposed in your container as environment variables?
Yeah, so the question is about Postgres user and Postgres passwords, so these environment variables here, that will be accessible inside my Postgres container. And the way that this Postgres image works is that it attaches onto these environment variables and will immediately set that user up. So instead of using just that default, Postgres user, I do have a user that I want to get set up, and so the way that the Docker image works is it grabs onto these environment variables, and then we'll immediately set up that user. Okay, so in summary, this is spin up a pod by that Postgres Alpine image. It uses the secrets that we defined beforehand, and then it's going to mount this directory to that persistent disk. That directory is the default directory where Postgres is going to save the data. So we create the deployment. And so this is going to immediately spin up a pod. And if you remember, I specified one replica. So kubectl get pods. See here the status is container creating, because it's probably pulling the image from Docker Hub. So if I want to get more information about what the hell is happening there, I can say kubectl describe pods, and then the pod name. And so, let me run that again. Well, you probably, I don't know if you can see that, but basically it's, so it's mounting a volume, and it's using that Postgres PV volume, and that's via the Postgres PVC claim. And then, you can't really see it, but maybe you can see it now, but pulling image Postgres 10.5 Alpine, so it's pulling that from Docker Hub, that's just a Docker image registry. We run that again, so it pulled that image and started the container. So now if we run kubectl get pods again, you can see that this is running. So I use the deployment to spin up that pod. So now we have Postgres going. So we have volume set up, we have the pod set up, we have our secret set up. Nothing can attach to Postgres now until we expose that port. And we just want to expose the port of 5432, which is the default port for Postgres, to other services in that cluster. So we're going to use a special service called cluster IP. So I think there was a question earlier about services that I didn't really answer, but there's multiple types of services. Cluster IP is sort of like your default service. That's if you want to expose things to other services within the cluster. You don't want people to have external access to it. There's a load port. That's kind of a hacky way to expose things externally. And then a load balancer is sort of like a step up from that. And if you really want to really get production ready, you want to use ingress. I'm not going to talk about ingresses today, but I will show a load balancer. So you can see here that under the spec, this is referencing my service. So this is referencing Postgres here, and then it is, I have my type here, and then I have my port 5432. So, I run this command here. So that created a service, and so now I'm going to actually set up the database. So if I run this command, kubectl get pods, grab the pod name. So I can run a command called kubectl execute. So this is very similar to the docker-compose execute command, which allows you to run commands against a running container. So pop the pod name there, and I'm going to run this command here. And this is going to create a new database with that user sample, and the database name is todos. So I'm going to go ahead and assume this is up. At this point, I could hop in pSQL just to make sure it's up, but for the sake of the demo, I'm just going to pray to those demo gods that this is up. Okay, moving on. So Postgres setup. On the node side of things, so we're going to use a node deployment that is going to connect to our secrets here. And again, that's where our database credentials are to spin up a pod. Pop this open real quick. Similar type of things, API version kind is deployment, spinning up a single instance of node here, I have some labels, and then under my spec, I have containers, and then that image, that's interesting, and there's an update comment there. We'll come back to that in a second. So, some environment variables, development environment or just the development environment, the port, and then the Postgres user and Postgres password that I'm grabbing from the secrets object that I already created. So going back here, so gcr.io, so that is Google Container Registry. So much like Docker Hub, Google has its own container registry that we can push containers or images to. And so I have a project ID here that I need to update, and then I'm just going to call it Node Kubernetes version 1, version 0.0.1. So if I actually pull up my spec here, and it's under right here. So if I change that, and the project name that I have is node-kubernetes, if I spell that wrong, that's gonna cause some trouble, and 1337. So now, so that's set up, the YAML file set up, but that image needs to be pushed up to the container registry. So moving along here, we run this command here. So this is going to authorize the container registry API. So you don't automatically have access to all of the APIs. You have to authenticate against them. So, if you're an administrator, running an engineering team, you can set up different permissions here. So you probably don't want to have, your lowly junior developers have access to everything. So you can start setting up permissions. So, and sorry for any junior developers out there. Didn't need to put that action in front of there. So, I don't remember what I said now, but, oh, sorry. So gcloud, authenticate, configure Docker. So now I am authenticated against that API. So I'm going to build this image. Already pre-built this, don't worry, so should go fast. And then I'm going to push this up to GCR. Hopefully this goes fast. Cool. Awesome. Okay, so now if I go to the container registry, take a look at Node Kubernetes here. You can see my version 0.0.1 tag. All right, so we have an image up, so now we can actually create our deployment. Grab the commands here, and then I'm going to run kubectl get pods to see the status. So inline image name. Okay, now I have to do some live debugging. Crap. Did I spell Kubernetes wrong in there? What the hell did I do? Kubernetes -1337. Does that look right?
I think it's pronounced Kubernetes.
What? Node-Kubernetes-1337. That looks right to me. Did I save it? Oh, I saved it, yeah. I'm referencing the wrong file. Okay. Okay, so I was referencing the wrong file there. So there's an opportunity to show you the apply command. So the apply command will diff what's different between the YAML file that is associated with Kubernetes at this point and the Kubernetes or in the YAML file locally. So apply should update that. It didn't for whatever reason. So, all right, so I'm going to delete it. And then start over. It's hard doing this with one hand. Like, caps lock is all jacked up right now. I don't even know why these keyboards have caps lock on them anymore. Okay, all right, so it's been created. Let's make sure the pod is up. Okay. All right, disaster averted. All these moving pieces, when one thing went wrong. Okay, so the pod is running right now. It's been up for 7 seconds. Cool. Okay, so let's go ahead and apply our migrations. So again, kubectl execute, and I'm going to run a connects command. Too many things going on here. Let me grab the pod name. Okay, so I applied my migration. So now I'm going to seed this thing with some to-dos. All right, so we have some data in our database now. Everything is set up, we just can't access it at this point. So we need to set up a node service, which the type is going to be load balancer, and so this is going to create a load balancer on GCP so that the rest of the world can access this badass to-do application. Okay, so the kind of service, some metadata here, you can see the type is load balancer, it wasn't lying. The type is load balancer, port is 3000. So let's create the service. So now we run this kubectl get service node command, and you can see it's pending. So it does actually take, I think, like a minute to spin this up. Let me actually hop over to the console here. So if I search for load balancing, okay, so it hasn't spun up yet. 30 seconds. So we're gonna have about 30 seconds of silence here unless someone has some questions, because I don't really have anything more to say, so. questions, someone fill the time.
So I'm working on a project that's just using the Google App Engine, and from what I see, that scales well on its own too. So I guess what makes Kubernetes better at that, or what's the deal there?
Yeah, so the question is sort of around Google App Engine versus Google Kubernetes Engine. So Google App Engine, for those who don't know, is just a platform as a service. It's similar to Elastic Beanstalk on the AWS side of things and Heroku. You know, if your application is running on there and it's fine, and you don't want to deal with containers, then there's not really any reason to move over, I would say.
Dumb question, but why would I want a container?
So why would you want a container? kind of another talk there about why you want to containerize things. Containers can simplify certain things and can make other things more complex. For example, like at work right now, I am running a web application so I have a UI application with a web service in the back end, and then I do a bunch of Spark processing on there. And so I can containerize everything and run it all on my machine. So instead of like having to code and then deploy it up somewhere and then to be able to test out the full integration, I can test it out on my machine. So that's one advantage there. So you can just kind of containerize all these micro applications and be able to deploy the stack wherever. Containers, they also help to decrease sort of the difference between your production environment and your development environment. So this is a Mac here, deploying Linux, some sort of version of Linux. So you can have, environment-specific bugs there. So containers help to decrease that. Containers can also help to decrease onboarding time for new developers. So being able to run a single command to spin up your entire ecosystem is an advantage instead of spending a couple weeks or maybe a couple days, I guess, spinning up things with Vagrant and whatnot. You can spin up your entire ecosystem with Docker.
Sort of related to that, would you ever use Kubernetes for local development?
Yeah, that's tricky. So the question is, would you ever use Kubernetes for local development? I don't know. So you can use Minikube for that. So Minikube is a tool that allows you to spin up basically a single node cluster, so you can pull everything on a single node. And it's great for local development, but that's so many issues spinning up Minikube and just fighting with Minikube that I don't think I could really recommend it for local development. And there's not really anything else out there. Sure, you can use Docker for that, but you're running your Docker stack commands at that point, which is very different than what you're going to be doing in production. So I would just use Docker Compose. Oh, and one other point here I wanted to make, and I know there's other questions, but I was saying you can actually use Docker to deploy against Kubernetes. And you can see that's my Kubernetes cluster right there on GCP. So I could point this at kubectl, or I could point this the same way I point kubectl at either my Kubernetes cluster or Minikube. You can do the same thing with Docker. So if you want to use the Docker API to deploy against Kubernetes, you can. Other questions?
I just have a quick question about, are you familiar with OpenShift? It's got kind of a flavor of Kubernetes. And is there pros and cons to using one than others?
I can't really speak to that. I know what OpenShift is. I've used it a bit, but I don't really have an opinion on it.
Yeah, I guess I had a question around, you obviously recommend using volumes as you're starting from scratch. But say you already have a production application, you have RDS instances, or if you're running Postgres somewhere else. Have you had any issue with having a Kubernetes cluster just speaking to those instances outside of the cluster? Does that work with production?
So you have an existing application that already has data in it.
Correct.
Yeah, in that case, you probably create your volume, and then you would figure out a way to migrate the data then to your volume. I haven't done that in the Kubernetes land, so I can't really speak to that. To be honest, I probably would not manage my own Postgres instance. I'd probably use RDS or SQL on GCP and just offboard that, and then as soon as that's up, then you can do your data migration at that point.
Yeah, in the same idea, is there a reason to containerize your database?
Yeah, I would probably say, so the question is, would you containerize your database? For demo applications, it's fine. It really comes down to that question of what do you want to manage? Do you want to manage a database, or do you want a service to manage it? So you can use RDS, you can, on the GCP side, you can use SQL, you can let them manage it. It's a little more expensive, but they're handling everything for you. They're doing like backups for you, blah, blah, blah. I mean, if you're really into that, then like you can do that. But again, it just comes down to like what you want to focus on. Do you want to focus on deploying an application, or do you want to focus on managing a Postgres database?
This might be outside the realm of this, but how would you do some like continuous deployment, like in production, say you have a new image, you push to ECR or to whatever the Google Cloud option is? Do you then have to update the configuration, or do you use like the API that just push that image with Jenkins or
Yeah, so continuous integration and deployment, you're right. I mean, it is outside the scope of this. There's multiple different ways of doing that. Spinnaker is a great tool for that. I would also, look at, you could do the same sort of stuff with Jenkins. So you're basically just running a build, running your tests at that point. And then you need to figure out a way to do some sort of blue-green canary deploy to update your application. Spinnaker handles a lot of that out of the box. I'm not as familiar with GCP as I am AWS, but AWS has a code deploy, which is basically like a Jenkins as a service. I imagine there's something on the GCP side that you could look at, but Spinnaker is I think it's Netflix tool, and that's definitely something I would take a look at. Other questions? Okay, cool. So this is up now, so now here is my external IP. If I actually refresh this, looks like it already refreshed, but you can see that this did set up a load balancer here, so now I can go to my browser to port 3000. You can see my Pong there. And then if I go to to-dos, you can see that there's my to-dos. So that was all spun up. So one last thing I want to show. And this is always like something that when I'm spinning up something, I don't trust those damn volumes. I want to actually bring down my pod and just check to make sure that the volume is there. So how can we tell that the volume is actually working? So let's make a quick change to our Postgres data. So if you go to this awesome blog post that somebody wrote, do have my curl commands here. So pop this open here. So this is going to delete a to-do, and I think that was like 1 is 1. Wrong endpoint. Forgot to-dos. Why is that not deleting? Yeah, you guys got it. It's like some crazy pair programming going on here. You guys gotta catch me on this. I didn't get a response back. Interesting. Did that actually delete? Okay, I didn't get a response back. Interesting. That's weird. Okay, anyways, well, it looks like it's, no, that didn't work actually. What the heck did that not work? Am I missing something?
HTTPS.
Singular to do?
Singular to do. Nope.
Does that be capital T?
Flat E.
Oh! What? All right, well, to-do deleted. That's interesting, okay.
I don't care for that. All right, 2 years gone. Okay. So where are we at now? So now let's remove the Postgres pod. Grab the pod name, cube cuddle. I promised you guys I was going to start calling cube cuddle, and then I keep calling cube CTL, so apologies. Cube CTL. Everyone's like, I don't give a crap. I'm the one who cares. All right, so let's delete that. And you can see right away that it's already spinning up a new one. That's because the deployment is managing that. It's abstracted out. The deployment says, we want one of these. Even if you delete it, we're not going to let you delete it. We're going to spin a new one up. So it's already spinning a new one up. That's running. So if we go refresh, should still have the same data there. Okay, so our volume is working. Okay, so if you do happen to follow this tutorial at home, make sure you remove the resources, otherwise you're going to continue getting charged. Putting up this disclaimer here, so not my fault. Okay, so what's next? I have a couple of things to check your understanding. We'll link on there how to encrypt your secret data, how to set up a better logging type system, and then diving deeper into your health checks. And again, a health check is for your load balancer to know that, hey, that instance that I just spun up is healthy. There's some resources here. I've linked to the slides, linked to the repo, linked to the blog post. And just in closing, if you're new to Kubernetes, learn the Docker basics first. Kubernetes abstracts out Docker. Start with Docker before you dive into Kubernetes. Dockerize everything you can. Dockerize 10,000 apps, whatever. And then learn about container orchestration, learn the Kubernetes basics, and then start deploying some apps, either the GCP or Minikube locally if you want. Okay, that is all I have. Should we clap or should we have questions? Or both at the same time? Questions?
I might have said this and I missed it, but at the very beginning you were talking about pros and cons of different systems, talking about Docker Swarm, means it's for smaller groups, and then Kubernetes made more sense when you have larger groups. What's large in that sense?
Yeah, I would say anywhere from 20 to 50. If you're going above 50 services, maybe start looking at Kubernetes. Question was, when should I start looking at Docker Swarm? What is a medium versus a large cluster? This is my opinion too. So I like Docker Swarm a lot better than Kubernetes in terms of getting stuff up quick. Actually, I haven't used Kubernetes in production. I've only used Docker Swarm in ECS. I am building out a proof of concept right now where I work on Kubernetes, but I prefer Docker Swarm just because it's so much easier to stand up things.
Have you run into any challenges with networking with ECS that were solved by switching to Kubernetes?
Did I have any problems with networking that was solved by moving to Kubernetes? Networking?
Networking between containers. So we've had a lot of problems with using ECS to scale a ton of containers with networking. That Kubernetes handles networking a lot better, it seems, but we're just exploring that right now.
I had, so the question goes back to networking with ECS. Did I have any issues with that Kubernetes solved? I didn't have any problems with networking with ECS as soon as the application load balancer came out. As soon as that came out, that just kind of solved everything. And maybe I wasn't dealing with the scale that you were, but I never had any problems with it now. Other questions? Okay, well, I will be around. It is 8:18, so I plan on drinking heavily until about 11 tonight, so if anyone wants to come out. No, I will have a couple beers tonight, but The weekend. But, so yeah, we're probably going to do a ratio or something like that. So if you're interested in coming out, chatting more about Kubernetes and whatnot, come on out. But Brooks, were there any online questions?
There was no relevant online questions.
Okay, no online questions, all right. Sorry, this is putting on your viewers. Yeah. Any redhead questions?
There was just one question about your GitHub slide.
Okay, all right. I'll handle it offline. All right. Well, thanks again. Thank you.
So that's what we got today. Thank you everybody for coming on out. We do this every month. We currently don't have a speaker for, next week's Node.js meetup talk. Our speaker hasn't confirmed with us, so we're assuming that they're not going to make it. We wanted to get a quick poll. How many of you would want us to actually hold the meetup as normal, or cancel it, or do something else? Shit. That was Thunderbird. Are you gonna do here, I'll step to the side so you can actually do it. So, quick show of hands, how many of you would want us to hold a meetup as is? All right.
I can do it in advance, Kubernetes talk. So this is what I was thinking. Node plus gRPC, so HTTP2. If anybody is interested in that. Couple people, HTTP2. Okay, Node plus Istio. Istio is a sidecar approach. Node plus CI/CD. Oh, yeah, okay. All right, okay. All right, well. Node plus Kubernetes plus EKS. EKS is, oh, no. I didn't even say what EKS is. Okay, well, EKS was I give you money. Elastic Kubernetes service. So, okay. So it looks like the CI/CD flow. All right. Anyway, did you have a...
So are you using Chaos or not one of those solutions for Kubernetes?
So on AWS?
Yeah, maybe that's what we could
Yeah, I can, are you asking if I can show how to do that?
Yeah,
or?
essentially. I guess I've been looking into this. I don't really understand pros or cons. It seems like they're very similar. I think you hit on basically what do you actually want to do, manage cluster versus applications. But yeah, COPS is
Yeah, so COPS is, from what I have found, is similar to Helm. It's just a package management system for Kubernetes. I haven't actually used it, so if I did a talk on it, it'd just be me hacking for the next week and a half, and then me coming up here and doing a little dance. But so all right, so it looks like CI/CD flow might be okay. All right, so we had 12 hands, maybe 13, maybe 11, but so I expect at least 11 to 13 people here if I did the CI/CD flow. All right.
Yeah, I'll change my vote.
You got something? Are you changing your vote?
Yeah.
You're saying you're not going to be here.
No, I won't.
You're I'm one of those 13. All right, we got 14.
My spot.
All right. Well, we can't do that. We got to commit to it. All right. So maybe CI/CD flow, Circle CI, that sort of thing. Okay. All right. Yeah. So maybe we'll have it. All right. After a few beers tonight, I'll make that decision. yes. All right. Cool. Thanks again for coming out. Grab more pizza and grab more beer, and I'll be around. Thank you.
Yeah, so one of the viewers found it. With your first slide.
Oh, really?
Yeah, great.
We're just looking at now, so we're kind of going through the flow way so that you need.
Yeah.
So a lot of the problems we're seeing is how do you actually discuss things consistently? We use Circle CI, so what you can do in integration Circle CI and use API. We're not sure what our CI tool do infrastructure changes. Spinnaker, I'll look into Spinnaker, I never read it before.
I've gone down that route, Travis. Yeah, I'm putting all the damn environments in there. And it becomes you need something else. And so yeah, you can look at Jenkins. Jenkins is not really set up to do that. And you have the pipelines in there. But Spinnaker works There's some problems with it though. I think it just hit 1.0.
Yeah.
There's some hairy things. It doesn't really tie together very well.
Got it.
Yeah, check out some.
Basically, like, do something like where